All right, so this is, I heard the term earlier, a wall of text. That's what you're getting. This is a set of slides that's going to feel more like a lecture, but it's also archival. So hopefully these slides will be useful to you in the future. I will skip through much of the content and stuff and go from there. All right, so first of all, I always want to acknowledge that I do nothing. The people that do the work are the students, and they're amazing. And lots of funding and collaborators and stuff. So about me, I'm a professor at Georgia Tech. I wear many hats. Technically, I'm a professor in psychology and a professor in interactive computing, which is fairly rare because those are actually not only different schools or departments, but they're also in different colleges. One is psychology and science, and computing is in computing. I'm also the director of the Center for Human AI Robot Teaming, CHART, and the Center for Inclusive Climate Communications, where we take what we know about multimedia, multimodal, and people and human factors and make information about climate available. A few other things, and I've been the past president of the International Community for Auditory Display. I am a researcher, obviously, do a lot of different things, but generally people and technology getting together, that's what we focus on. One of those things ends up being universal design and assistive technologies. We often use multimedia, sound, and sonification in our work. So that's shouldn't surprise anyone. I'm an educator and an entrepreneur. I have lots of things going on. I can't sit still. I always stay busy. So one of the net results is I have, sadly, this never-ending supply of, oh, we did a project once. That probably is, related to whatever is being discussed. My lab, which is the more interesting part, is also split between School of Psychology and the School of Interactive Computing. My students come from all over. They all sit together, and if you walked into the lab, you would not be able to look at any one of them and say, computing, psychology. If you started to talk to them, you still would not be able to talk to discern who is in what program or another, because they all work together and they all kind of grow together and are functionally cross-trained. So we have students from all over the place. Yes, we have jingles. You heard the first one. We also have this other jingle variation. I guess I have to turn my speaker off. Let me try that again. For whatever reason, I heard it here. No.
Heard it fine on Zoom.
So, okay.
Yeah, let's just do it. You can move the microphone to.
Oh, you think it's getting. All right. Well, whatever. So those jingles we use when we're making videos and demo reels, and whenever we're on the radio or the TV or whatever, throw that in there as a bit of branding. Okay, so what I want to talk about today is adoption of sonification, particularly in STEM, science, technology, engineering, and math. And we don't need a history of sonification. That's available in lots of ways and lots of places. But I do want to point out sort of what Carla was saying. There has been an ebb and flow of the adoption of sonification. And by this, I sort of mean more in the formal sense than sonification, even though I think the use of sound has largely continued. So in STEM, in science, why, right? Well, one interesting way of looking at this is from this background of technology acceptance model. And it goes back to Davis and others, and there have been many variations of that. And it boils down to trying to think about the perceived utility and the perceived usability. Those are the two main things that are at the heart of this technology acceptance model. So you want to have something that has high utility and high usability, and people will somehow magically adopt it. That's sort of the core of that. But it turns out that sonification can be thought of differently because it is a futuristic technology. And futuristic technologies are actually different from others, or we make this adoption or acceptance decision in a way that's slightly different from other technologies. And I'll talk about that. And in particular, hot off the presses, one of my students, Hannah Neroy, is studying the adoption of futuristic technologies, and we have a model of this acceptance. And what really is unique about this and the contribution of MAFT over TAM is that it adds more emphasis on perceived risk, trust, and emotion. And I'll talk about how that plays out, but I think it's really quite interesting how a sonification could be thought of as a futuristic technology, and then what can we do about it? Okay, kill some of these little things here. Okay, so generally speaking, if we go back for a moment to the TAM model and the core of these things, perceived utility and perceived usability, in the perceived utility bucket, we want to have things like a theoretical grounding, scientific utility, scientific validity, replicability, standardization, educational utility, accessibility, inclusivity. These are things that are generally in the value bucket, right? Then the perceived usability, these are things, well, is the software available? Is it easy to use? That's sort of the traditional usability. But is there training? Again, standardization. Is there a community of users that can help you? Is it portable? Does it ecosystemic integration of tools means if I use sonification, but I can't put that sonification in a publication, it doesn't fit in my ecosystem, right? So we have to think about what is the ecosystem that involves students who join your research group and have never heard of this tool. Now you've got to teach them, right? So integration into the ecosystem, and of course, accessibility fits in this bucket as well. So all of these things are pretty straightforward when you think about adoption of technologies. And how are we doing? We could give this sort of a perceived utility report card. Okay. Well, lots of text here, but generally speaking, if you think about the theoretical grounding for sonification, we have chapters and that are called the theory of sonification. We have people who have written about this. So, all right, there's some of that. We have vocabulary and things like mappings and metaphors, polarity, scaling, context. We have ways of interacting. So theoretically, there's some theory related to sonification. What about scientific utility? Well, there have been demonstrations that sonification can add value, can lead to discoveries. We talked about some of them. Several of us have written papers that have historical references to various, the Cassini mission is often cited and other kinds of things more modern to that. And, as we've heard, I can show you examples like the skin cancer diagnosis. If I can save lives by using sonification, that is at least one proof point that there can be value added from this. And is that good enough for it to exist? I don't have to say that in every field, in every scientific endeavor, sonification has to be or may add value, but it has been shown, right? What about the validity? Well, there is relatively limited validation, and there's some kind of evaluations that happen, but that's probably a bit of a sore spot. Although I will say again that cancer detection, we've had formal clinical trials, so that's at the most rigorous level of validation that our scientific endeavor generally experiences. Replicability. To use the sonification, yeah, nobody replicates. Now, that's not to say we have a replicability crisis, like we talk about in psychology, right? It's just that no one does replicate. The field is so new that we don't have this luxury of going back and redoing what someone else did 11 years ago. Now, some of that is because it's hard to do that, because the code and the stimuli and even the hardware and all of that stuff may not exist anymore. So it's hard. But also the churn is so fast, we're not, no one's going back and saying, oh, I'm going to go replicate how they made AI engines 4 years ago. Why would you do that? Well, it might be useful in some ways, but it's not practically relevant. Standardization, another sore spot, I guess, or a room for improvement, if you will. We don't have a lot of standardizations. There are some de facto standards, the tone plot, the auditory graph, where you have time along the x-axis and you have frequency or pitch on the y-axis, or y data are represented by changes in pitch. That's pretty standard. But even that, there's not standardization in terms of how you represent the axes and the tick marks and trend lines and all of the context. Is, as we talked about with Scott, is it bum, 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 bum? Or is it a glide? Or is it, a series of discrete tones, right? We could say, well, those are different things, just like there's such a thing as a line graph and there's a scatter plot which has a bunch of points. We call them different things, we use them in different ways. It's fair to think that sound could be characterized in those same kind of ways, but we don't have standardizations at all. That's not our fault. It's just that we're young. I think it's something that would emerge. If you go back and you look at the earliest visual graphs and visual data representations, they're all over. They're all very variable. So, okay. As it relates to more complex forms of sonification, there's no standardizations. It's Wild West. It's every person makes something that's unique to their situation. So that is what it is, right? All right, well, what about educational utility? Well, again, we're relatively limited in terms of the applications and certainly the evaluations. But I will say that of the few situations where sonification has been employed in classroom settings, it has generally been found and has been evaluated effectively. It works out. It's a good thing, depending on what exactly you're trying to measure or what you're trying to impact. But generally, it's a positive a value add for education. Of course, there are these ongoing challenges related to usability and accessibility, and also the ecosystem, right? So if you're a school teacher, you may find out that you have all of these wonderful Windows computers, brand new Windows computers in your classroom that don't have sound cards. Or they have sound cards, but there's no speakers. I mean, this is the reality, right? And so now, how do we design a multimodal experience into that ecosystem, right? So we have to recognize the whole picture. Okay, what about the other side of things? The usability. I'm sorry, yeah, yes, I'm advancing slides. I'm now on perceived utility. and now moving to perceived usability. Thanks for that reminder. So in terms of perceived usability, there are software tools available, but they're at all various levels of power, sophistication, tech stacks. Some are aimed at more general use, some are more specific or broad. You know, Strauss is much more of a kind of like, you can do anything because it's programming, right? There are some general education tools emerging, and you're seeing some graphing packages and so on. But it's kind of a mixed bag, I would just say, in terms of the software tools that are available, and how easy are they to actually put to use, varies greatly. We have historically, for the last 30 years, had this challenge, as we've discussed already in this meeting, that many of the tools have been one-offs. They haven't been designed or built for the purpose of broad dissemination. They've been built to help someone get through their dissertation. And other people thought, oh, that's kind of cool, I'll try that as well. But they're built by chemists or astronomers or whomever trying to do something with their data, and those people are not necessarily skilled or even trying to make a usable thing. So the usability of these software tools varies greatly, and often there's no training for the same reasons. We don't build training tools to support our research tools when we're experts in all of those and how to get things done, right? So very limited, but there are some examples. We heard about some examples already here at this conference of how-to videos and README files and all of those kinds of things that are helpful. But we're getting there. Standardization, which leads to usability, is a problem. If you were to use Strauss and then you were to use Stronify and you're to use Sonification Studio, just to use those three examples, the interaction's different in all cases. The terminology is somewhat different in all cases, and so it's hard to have those things be usable. Contrast that with, say, word processors. You can go from one word processor to another word processor to another, and they have similar modes and vocabulary and file open, file close, file save, insert, bold, italics, new paragraph, right? All of that is common across these different platforms for word processing. All right, what about usability as a community of users and support? Yes, but small and fragmented. There's no real financial support for sustainability. It's a very small-ish group of people. We rely on the kindness of strangers to a large extent. You build this software for your own purposes and you make it available, and then someone says, oh, I like this, I'm trying to do this other thing with it, can you help me? Often we will do that because scientists are often quite collegial, especially if someone wants to use your software, you're going to help them use your software. Maybe you'll get a citation out of it or something, right? Like, ooh. Portability, almost none. There are some examples like the HSSP file for the high chart Sonification Studio project file, and things like max patches and on super collider files, and things can be interchanged and made portable, but still limited. The ecosystemic integration of tools, again, very limited, hyper-local. That is to say, I can turn my data into sounds and then figure out how to put those sounds into my materials for teaching or whatever, but it's just my local solution in many cases. And accessibility, hit and miss. It really depends on how you build these things, whether like Jupyter notebooks, we know are not particularly accessible to users with vision impairment or screen reader users versus HTML, which is a lot better. Yeah, so I'll just say the accessibility. So where do we land with these report cards? Next slide, to summary grades for sonification acceptance. So again, going back to the sort of technology adoption model, the traditional TAM version where utility and usability are what we care about, maybe we get a grade of something like B for utility, but probably closer to failing, like a grade of D for usability. The exact, if you want to argue for grades, I won't have it. You're not getting a B plus. So we got to do more. But what can we do, right? That's the existential discussion. What can we do? And so I have a couple, as a bit of a break from this wall of text, a couple of examples of things that I would posit as sonification applications that are both demonstrating utility and usability. So they ought to be high on the technology adoption or technology acceptance framework. So one example here is the sonification of skin cancer that we talked about. I'll play some examples. Hopefully it works out. If not, tech guys here. This is a benign skin lesion. It's a sort of a brown spot on a pale skin, and it's what we would look at on our skin and call, oh, that's a mole, right? We have come to know these things and know that they're benign. Play it again. Right? Then there's this another image of something that is identified as malignant skin lesion. And when you look at it, it's repulsive. It's like, if that were growing on my skin, I would not let it get this severe, right? And so this may not be the best example of the audio, but right, I'll play that again. It's louder, it's more onset, it's higher frequency, there's ringing, there's repetition, it sounds categorically distinct. And when you hear a lot of these examples, you start to hear the benign sounds or the sounds of a benign lesion sound kind of benign. They kind of blah, kind of vanilla. And the sounds that represent a cancerous lesion sound kind of scary. So if you were listening to these to try to determine whether that thing on your skin is skin cancer or not, you could absolutely tell with no training about, you know, certainly the ones that are on the extremes. The ones in the middle, more training helps, but people are still pretty good at doing this. We took the human out of the loop and made a classifier to classify the sonifications. And that's where the sonification layer comes in. And then we added that extra 10% of accuracy, but you don't need that secondary classifier. You can just listen to this like a skin cancer stethoscope. On the bottom right of the slide here is a screen grab of a tool or a demo video that we have. There's a link to it here. You can go and look at all kinds of tumors and see the classification that they have, and listen to the sounds that are representing those skin cancer examples. One thing that you'll see at the bottom of this screen capture is what looks like a histogram. Pardon me, it's a histogram. just technologically, what we've done is instead of taking the output of a classifier, which has really a binary yes or no or malignant or benign classification, we go one step in to the penultimate layer of the classifier. And so there's 1,024, 1024 nodes, just one layer in, and we sonify those nodes. That's what we do. And so each of these lines, vertical lines in the histogram, represents the intensity or the value at that node, and therefore the value of a particular pitch. So things that are benign are going to be more weighted to the left side of this, lower frequencies, less onset, less repetition. And then on things like that are malignant, such as this case, we'll have more activity, more peaks to the right side. So it'll result in a more high frequency. So this is, again, you imagine the piano keyboard laid out in a way to kind of make sense of what you're seeing here. All right, more to be said about that, but I'll just move on. Oops. Okay. So another example of what I think is utility and usability combined is a project that was done by Ora Walmer and my group. Ora joined us on Monday. And this is a sonification of the path of totality of the solar eclipse that happened last year. And I'm going to play the first part of this in its entirety for a specific reason. So hopefully this comes through.
April 8th, 2024 marks a rare astronomical event, a total solar eclipse, during which the moon blocks the sun completely and the sky darkens. Viewers along the path of totality, which moves in a northeast trajectory across the United States from Texas to Maine, are able to experience the full effect of this phenomenon. This is an audio-visual map containing a guided data sonification of the path of totality. Consider the contiguous United States and imagine it bounded by a rectangle. You have Washington State in the upper left, Southern California in the lower left, Florida in the lower right, and Maine in the upper right region of the rectangle. Let's use this as a framework for our sonification. Latitude is mapped to pitch in the key of G major. Longitude is mapped to stereo image position, that is, the audible presence in your left speaker versus right speaker. Here's what Seattle, Washington sounds like.
This would be in stereo.
Here's what San Diego, California sounds like. Here's what Miami, Florida sounds like. Here's what Portland, Maine sounds like. The path of totality starts here and ends here.
Again in stereo.
These are our reference points. Now let's hear the full path of totality. You'll hear a sequence of ascending arpeggios. The timing of these arpeggios is dictated by how long the path of totality lingers in a given longitudinal coordinate value. Along the path, you'll also hear flourishes, which indicate major cities. Austin, Texas. Dallas, Texas. Little Rock, Arkansas. Indianapolis, Indiana. Cleveland, Ohio. Buffalo, New York. Did you hear the stereo imaging effect from left to right as the longitude changed? Did this sonification give you a
No, of
sense of
course.
the eclipse's trajectory? Let's listen one more time for
We won't. Okay, so I point this out for a number of reasons. First of all, it reinforces the ecosystem point I made earlier. This is designed with stereo, assuming you have headphones or speakers. We don't have that here, so the mapping breaks. Okay. But what is the purpose of this? All of this preamble. Aura spends all this time giving you basically an orientation, and it takes 2.5 minutes to get you oriented for a 20-second sonification, right? I would say that's probably what's required. You have to give people that scaffolding, or else they're going to hear it and they're not going to know what they're actually hearing, right? Now, if I wanted to do a different trajectory, compare two different ones, I wouldn't have to do all that preamble. Or if you listen to it again tomorrow, you could advance past all of that because it's one-shot learning, right? You've already been educated on that. So I would say that's an example of how you have to bring people along, probably on a sonification by sonification basis. Rose was pointing out that you can have text description, and that can be converted into, use text to speech, right? Convert that into speech so that you can have your caption spoken aloud, right? That's wonderful. So my point is that if you're going for utility and usability, you have to think about this. This is a public outreach activity. This is the kind of thing that is intended for the public, right? It's not intended for science. So it may not be as precise. It may not allow discovery. It may not be sciency. It's more ethereal, more artsy. Those are all design choices based on who our intended audience is. So, all right, I'm going to move on beyond that and say, okay, well, what about this model for the adoption of futuristic technologies? Okay, well, certainly the concept of perceived value plays a role here. We call it perceived utility and technology adoption model stuff, but the value has to be clear. But one of the additional things about this futuristic technology is that we really highlight the need to manage perceived risks. Now, it turns out that there are a lot of flavors of risk. I've listed some here. For example, financial risk. What is the potential loss, right? Performance risk. Could I fail? Could I not do my job? Could I get a lower score on the exam, or whatever performance means? There's social risk, right? If you are adopting a certain technology, is there a risk associated with doing so? I don't know, maybe there's a sort of futuristic thing like a Tesla Cybertruck. That's a choice. And people made choices based on certain things. And now there's actually backlash on Cybertruck owners. That's purely a social risk because people are associating Cybertruck owners with Elon Musk. And that's not fair, but it is what it is, right? There's also a financial risk of having a Cybertruck because the value is plummeted, right? So there are different kinds of risk when you choose to adopt any kind of technology. There's psychological risk. This thing could cause you emotional harm, like the fact that our children can't hold a conversation because they're so used to texting, right? They cannot, handwriting is no longer taught. These are sort of more sociological or psychological risks There are time loss risks. The technology could be late, delayed, inefficient, require extra effort. There's ethical risks, there's privacy risks, and security risks. These are all different kinds of risks that people evaluate when they're trying to determine whether I adopt this technology. And the converse of these risks is also part of the perceived value. When people say, oh, I'm going to get an iPhone, right? One of the benefits of having an iPhone was the white headphones, so that everybody knew that you had an iPhone. And that was a differentiator. And then you could be part of the cool kids club, right? So there's all kinds of things to think about. In addition, we look at trust. Another part that is at the very bottom of this slide, which is affective components. This is emotion. The earlier models of technology adoption didn't really consider the humanity, didn't consider the emotional considerations. It was all about the utility and the usability of the technology, not the people who would be perhaps using that technology, right? So we're surfacing that as a much more salient element now, okay? All right, so next slide. What can flying cars tell us about sonification? Wait, what? That was a bit of a transition. What can flying cars tell us about sonification? Well, let's back up and we say adoption of any technology, getting scientists to adopt a technology like sonification, first of all, requires acceptance. And we know something about the acceptance of futuristic technologies from this MAFT model that I've just been discussing. And it turns out that in my lab, we study the adoption of futuristic technologies using flying cars as an example of a futuristic technology. It's something that we all can kind of wrap our heads around. I kind of know what a flying car ought to be like, but I don't really. And it's kind of cool and kind of scary. And will people think I'm a nerd? And is it going to crash? Could I die? What are all the benefits? What are all the risks? Right? So it's one of these examples where all of those different kinds of considerations come into play. So we use it as a platform to study the adoption of futuristic technologies. This is an example of one of the flying cars that we use, and we simulate. We build flying car simulators. Here's an example. So you can see the outside of the flying car, but you can also sit inside the flying car, and you can be a passenger. Like imagine this is a flying car Uber. So you can sit in the back seat, or and the Uber might have this flying car might have a human driver. So we can put an avatar in the driver's seat to kind of drive, or we can leave the driver's seat empty, like a Waymo, where this is a flying car that is completely self-operated, okay, autonomously operated. We can have the people sit in the driver's seat and drive, and then they pull over and they hit a button and they go into flight mode, and it takes off and they start flying this vehicle. And then we had to demonstrate how that would fit into the ecosystem. So for example, we had to come up with this concept of a vertispot. So you may have heard of a heliport, where helicopters take off and land. And the concept for flying cars is a vertiport, where you have a place that you would go, just like a heliport. And often it would be kind of in the suburbs or something like that. You drive out to this heliport, vertiport place and take off and fly somewhere, land at another vertiport, and then start driving again. So for interurban or city to city or town to town transit. Well, for us, we think this could be downscaled, so you wouldn't need a vertiport like a heliport or an airport, but a spot, a vertispot. So imagine a space the size of a gas station. So you would just drive into it, drive off the road, and then you drive into the circle, flip the switch, and then when it's your turn, you flip the switch, and then you take off, and you fly through the city. So we can simulate that, and here's the view from the air of flying cars as a research platform. So just as an example, we do all of this. All right, so back, the next slide is, so what can flying cars tell us about sonification? Well, turns out that flying cars and sonification both share some of these attributes of being a futuristic technology. We need to make sure that we're aware of the perceived value and the perceived risks of both of these. And there's some interesting phenomena that happens in futuristic technologies, including both sonifications and flying cars. One example is what we call temporal discounting. I spent a fair amount of time talking about all these perceived risks. And it turns out that the farther away something is in time, the more we discount the risk. So I can ask you, would you get in a flying car next week? And you might be like, maybe. Okay, on a scale of 1 to 5, where 1 is definitely not, 5 is definitely yes, maybe you'd give me a 3 or something like that. Man, okay. Now, if I ask you, would you get in a flying car 10 years from now? We're like, sure. I assume that by then, it'll all be good. They, whoever they are, right? They will have figured it out. So there's this perception that things farther in the future are less risky, temporal discounting of risk. Do you think they should adopt flying cars in your neighborhood? Do you think they should adopt flying cars in San Francisco? Sure. It's the other side of the continent, right? So both temporal and geographic distancing, distance effects relate to whether people are prepared to adopt these futuristic technologies. Another aspect is familiarity with these kinds of things. When we cannot picture something, we tend to assume the worst. When we are not able to conjure up, when we have what we call a failure of imagination, we tend to think it's probably worse than I thought. So if you say, you know, do you want to experience, do you think you would take a flying Uber or drive a flying car or purchase one or lease one? People generally like, that's kind of scary. Okay. Then we can put you in the VR simulator, let you drive it, let you fly it, let you be a passenger. And then we ask you again, now that you know exactly what we mean by flying car, now you know what it's like, what it's going to be like. Would you adopt it? Would you use it? Would you get in it? The answers are always more positive. Familiarity and being able to make a concrete understanding of something rather than just some loose sci-fi imaginations is always good. The emotional aspects is also a big part of this. So if we put people in a flying car, in the flying car simulator, they get in, they're in VR. They're sitting in a chair in a room. It's perfectly safe, but they're still nervous. Weird, but human. We put the VR headset on them, or they sit in our flying car simulator and they experience it. And they're like, oh, oh, that wasn't so bad, right? From a visceral experience perspective, their emotional response is more neutral. Then they have the cognitive experience. They're able to, they don't have to guess or imagine what it might be like, and the emotional or the fear factor has been overcome. Then you ask them, would you adopt this? And they're even more likely to say yes. Okay. I say all of this to point out that when it comes to something that's futuristic, we can manipulate people's adoption through training, through familiarization, through emotional aspects, and through safety and managing risk. So what do we have to do for sonification? We have this perspective. Many scientists, we heard this, I think this is almost a direct quote from someone earlier this week. Many scientists say they would never trust or they would never use sonification due to lack of perceived value, possible limited trust, possible perceived risk. That quote is really talking about the same concepts of this adoption of futuristic technology. So if we manage perceived value by conveying all of the value, all the ways that can help you, that something provides utility, we manage perceived usability, okay, but we also manage perceived risk, showing people that there are fewer risks or identifying where those risks are and mitigating them, and then providing evidence from effective and thorough evaluations. One of the biggest perceived risk is it's not going to work, but another one be reputational risk, right? What if I try this thing and it doesn't work and I'm going to look like a fool with all of my PhD peers, right? So if we can make sure that we have built these things well, collected the evidence to show that they're useful, to show that they work well, and iteratively improve them, we can help manage that perception of all of these different kinds of risk. And of course, managing trust and emotions comes from all of the above, right? So where do we get to? This is a bit of a nice reminder to talk briefly about evaluations. Again, it's a theme that has come up over the week, and I'll remind us of what I tell my students every single day. When you're constructing evaluations, you have to think about evaluating performance, preference, and affect. PPA is what I drill into them. All of these things can matter. So performance, if you are building a tool that is trying to help you hear a particular event amidst noise, does it do that? Can you hear those things? If you're trying to figure out bum, 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 am I getting richer or poorer? And you're trying to figure that out yourself, is the tool successful in that? If I'm trying to convey that to someone else, do they get the message? That's performing the task, doing the job for which this display is created. So absolutely measure performance. We talk about, the scientific utility or something. That's doing what the researchers need it to do. That's the performance. But that's only 1/3 of this triangle. We also have to make sure we're measuring and evaluating preference. You can make something that is very effective, but sounds terrible and people don't like it. They don't like to listen to it. Maybe you have to leave it that way because that's what actually is effective for now. But at least knowing that people don't like it is something you can measure, and then you can work on that. And then measuring affect and emotion. I was delighted to hear Kim's talk yesterday when she said we measured motivation. That's an emotional, affective thing, right? If you're making a tool for school kids, and one of the things it does is makes them want to go to school. Oh, that we did, mommy, we did this sound thing. We're going to do that again tomorrow. I'm going to get up early and brush my teeth and get ready to go on the school bus, right? We call that engagement in education. Nobody knows what engagement is, but it's that, right? So if your tool helps a blind scientist be more independent and they feel empowered, measure that. Empowerment is powerful, right? That's one of the things you want to do. It's not all functional, like get the job done. It's like, I love doing this stuff. I'm going to convince other people to do this stuff as well, right? So measuring performance, absolutely. But don't forget preference and the many things that are related to preference. And don't forget the affective, visceral, emotional response. These are big buckets, and the boundaries between them are kind of blurry for sure. We get that, but it's a reminder to spread your evaluation coins around. We talk about things like perceived workload. You have the NASA TLX, some of you may have heard of, right? How much workload, how stressed am I when I'm using this system? That's whether you call that a performance preference or an affective thing, I would probably put it in the emotional or affective bucket. It's a perception of how suckish was it to use this thing, right? Measure that. So it may turn out that pilots can fly this plane, but they were hating every minute of it, right? We've had this kind of experience where we've built applications in our driving simulator, and people were driving, but at the end of it, they were white knuckled. They were gripping the steering wheel so much, right? They performed in the driving task the same as everybody. But at the end, when we say, you know, how was that? And they're like, oh, that sucked. Right? So we wouldn't have known if we had just asked or looked at performance. So we want to design for all of these things. Make sure that all of your designs are considering all of these, and then you evaluate them and you iterate on all of these things and you optimize in this multivariate way. Lots of examples that we could get into, but I'm going to wrap up and remind you to consider the entire ecosystem. Demonstrate value, manage the perceived risks, design, evaluate for performance, preference, and affect. And all of this is captured in the fun term enjoy-nearing, or kansai engineering. This is like a very common thing. And with that, I will say thank you.
All right. Do we have any questions for Bruce? Yep. Okay. Carla's winning.
Can I go off topic and ask about your new robotic guide dog? I want to hear about it.
Absolutely. Why don't we
LinkedIn.
put a pin in that, and I'll come back to it because it's relevant here, but I want to see if there's any sonification things first. But sonification, you know what? We'll talk about that because there is sonification in it. So what Carl is pointing out is that one of our many projects is to develop a robotic guide dog. This is a four-legged robot the size of a Labrador, very much modeled after what you would expect if you had a Labrador or that kind of dog. Put a harness on it, train it for years to become a service animal. There's lots to be said about who would use this, why, whatever, the adoption of, for us, it's also a research platform, right? I'm not in the business of making, we don't have a company that's going to start producing these things for us. It's a fully functional research
It's a
platform.
futuristic technology.
It's exactly a futuristic technology, and all of the same things apply. So we have to think about the performance. Does it get you where you are? But also, was I afraid when this thing, was I afraid of this thing? Was I afraid when I was with it? Was it afraid of me? Were other people around me afraid when they saw me coming down the hallway with this robot, right? So the performance, the preferences, the emotional or affective, all of that gets considered. There's sonification involved in it. There are alerts, both from the robot to many, to the community or to the people around you, from the robot to the person, from the person to the robot. There's human robot interaction and communication strategies. How do you want your robot to talk to you? Right? Well, we got a PhD student working on that, and it turns out that everybody says, I would prefer my robot to have a warm and friendly human voice. It turns out that that preference is universal. It also turns out that people will listen to that robot less than they will listen to a robot that sounds like a robot. So there's a difference between liking it and complying. When the robot says stop, or you might want to stop, right? So we had to study all of these many aspects and factor that into that. Iterative, and of course built with and in closely with a large group of co-designers, people with vision impairment. Other people who might use such a device are military personnel who use it for other purposes. We have search and rescue applications. We have, so we have all of those stakeholders involved. We have to look at things like the form factor, not just, well, so I'll give an example that's probably relevant here. When the engineers build those robots, they intentionally make their gait a very high stepping gait. They step very high so that they don't trip on stuff, right? It also gives them more time to figure out where to put the foot down. So computationally, it's savvy, right? The one of the results of that is that the robots are noisy. They're putting their feet down like this. And that thing's walking down the hallway with you. You're just going to the restroom. Here comes Bruce. Right? We had to work with the programmers to make a quiet stepping robot, because clearly that noisy robot was unacceptable for any of the use cases that we had. So we had to find a way to have the engineering issues solved, but also the human issues. So, so that's a bit of an adventure into that. We'll talk more, but
You need beta testers.
sure.
Okay, we have Amy online, but Scott's hand was up before then. Okay, Scott is being benevolent. Amy, you get to go first.
Oh, thanks. I think this was interesting, Bruce. Thanks. And I will save this PowerPoint presentation. But as I was listening to you talk about what determines whether someone's going to take up a technology, I was thinking about my own case. And I think this is woven into your thoughts, but I phrase it a little bit differently, is that I look at the cost-benefit ratio. What is the cost of taking it up, which usually means learning it, right? versus the benefit. And I can relate this exactly to whether to take up trying to sonify data or not, my data. You know, should I? Here's this, just to use your tool, high chart sonification studio thing. Okay, I got to sit down. I got to invest some hours here trying to figure out how to use it, especially with a screen reader if I'm going to do it independently. You know, what is the cost of that versus what am I going to get out of it? Is it going to work? Is it going to work for me, my application, my use case? You know, pretty unknown for me when I started. Still a little bit unknown, actually. So it's just a different way I look at it with that cost benefit ratio and how I analyze that up front before I start.
Thank you for your comments. I think that absolutely. I mean, the cost benefit ratio or the cost benefit balance is something that we use for all technologies or all of our decisions, whether you're buying cereal or whether you're, going to get a car or a bus pass. Like, it's cost benefit ratio. That's a large part of what we do. The thing with the futuristic technologies is that we can't always do that math as well. For example, what is the cost of a flying car? It's not known. So we have to make it up. And that's one of the hallmarks of these futuristic technologies, is that the cost benefit ratio is not calculable. And so we go more with our gut. We go with what we've heard. We go with what someone has told us, with what we've seen in science fiction or what we believe to be coming down the pike. So, yeah, the cost benefit ratio is bread and butter. But these weird things that people can't necessarily wrap their head around, or they don't know what the cost benefit ratio is going to be like for sonification. For many people, it's going to be more emotional, and it's going to be something that we have to manage in a slightly different way. In your case, I think you can wrap your head around it a lot more, and it's not a futuristic technology for you. So you probably are just looking at the perceived value and the perceived usability and seeing, treating it just like kind of anything else. So that makes the point that not all, like a futuristic technology is not separate from the people. So, like there was a time when microwave ovens were futuristic. And for some of us in the room, they came into the kitchens in our lifetimes, right? So when I was a little kid, we didn't have microwave ovens, but then we got one, and it was all big and scary. And we talked about, could you get close to it? Should you stand back? Am I going to get sunburn from this thing? Like, what exactly? We didn't really understand it. We didn't know, but it was just somehow faster than boiling water or whatever else. So there were some values, but it was a weird situation that, so microwaves were a futuristic technology at the time. Now microwaves are an appliance, and they're so not futuristic that we use horrifying words to describe them. Like, you have a muffin and you want to heat it up. What do? You nuke it. What in the actual F is that? First of all, it's not correct, because most of our microwave ovens don't use nuclear technology. Right? But just like, it's just commonplace. So we talk about these things just like toasters. But there was a time, and when we got a microwave oven in our house, we were early adopters and we were fine with it, right? But other people resisted because they were more skeptical, or their risk function was different. So there's a lot of individual differences and subjectivity in all of this. And that's why the word perceived risk, perceived value is so prevalent throughout all of this. Sorry, that's a long answer to your question, Amy, but
Thanks.
So Bruce, I've been thinking a little bit about how best practices and effectiveness rightly say that when you're using sonification, you should spend the time like Aura did to have that pre-narrative to set a lot of important stuff, right? Which naturally makes these things longer in time.
Yep.
That's in direct opposition to many other things culturally, right?
Yep.
Media, both traditional and social, are getting shorter and shorter. Presentations. Can you actually give 8-minute presentations at AAS? How about 7 minutes? So a lot of both education, outreach, news, media, and also even professionally, we're getting more and more forced to provide more information in less time, yet best practices for sonification say, don't do this, right? Make your 30-second clip 2 minutes and 30 seconds. And a lot of people probably stopped watching that thing before you even got done with the first minute of it, right? So, I mean, it's not a, I don't expect an answer, but what are you thinking about for that, I guess, if anything?
It's a complex trade-offs in a complex design space. I mean, that's, you know, if you want people to understand and really grok your message, then you have to give them the context and the framing to understand it. If you want this just to be filler, right? You can have a complex visual graph, and if people don't understand what a logarithmic axis is, then what do? Right? Do you point that out? Do you have to educate them at the beginning? Yeah. I mean, at some point, people will bring into the experience more lived experience. They will have familiarity with these things. They've heard a tone graph, right? An auditory graph. And now you don't have to explain it to them. So we're talking about, we're building this new version of what we call a more inclusive hurricane tracking map, right? Because the current hurricane tracking maps generally are kind of mid, kind of average, right? And one of the things that you need to think about when you're using a map for people who have vision impairment is that they need to have a description of the map, of the landmass, right? So we can drag that around and say, okay, here's a map of the southeastern United States, the Caribbean Basin, and the Florida Peninsula and the Leeward Islands and what have you. And here's where right. I could spend 30 minutes describing the landmass and then get to the hurricane map. Or I can offload that and have what we're calling wiki maps, which would be a shared repository of descriptions of maps. So go, if you're interested, and then I would just include that by reference. I would say, go to, here's a hypertext link to Wikimapps that will describe this. For the first time, you can go get this, spend all the time you want to become fully familiarized with a description of the geography of the Southeast United States. And then come back, and then we'll talk about hurricanes.
That's where standardization is so important, right? Like,
it's an ecosystem. Yeah.
Weather channels to explain that we're using this color code. Every TV station has a map of temperature, just the same exact one. You know what that means.
Yep. Yeah.
We don't have that in a lot of cases yet.
Right. Yeah. So we have to be creative in the way we design things, be prepared to expand the ecosystem. We just want to have a map of the hurricane, but now we have to have wiki maps as a whole new thing. Okay. So it is. Right. And so it doesn't mean you have to drag around and make your sonification super long, but if we had a way for people to learn that, then they come right to the guts of your,
So I would like to play the devil's advocate.
Please.
So, I mean, I think that you and Michael have created this unassailable argument in favor of human factors. I mean, I didn't need to be persuaded, I already was. And then on efficacy testing and evaluation. No, there's zero argument on that. But to be the devil's advocate, I don't want the astrophysicists to spend time doing surveys. I don't want the astrophysicists to, I mean, their like years of education and specialist training and knowledge, I want them to be doing astrophysics and not to spend time on making surveys and doing the statistics on their surveys.
Yep.
Is there a way, can we like imagine a way for specialists to work cooperatively so the astrophysicists focus on their research and the human factors people post or I guess you don't want to do it post hoc, you want to do it together, do the evaluation part. Because I want to see the astrophysicists doing astrophysics.
Yeah, no, 1,000%. Right. How many astrophysicists in the room have used Microsoft Word? How many astrophysicists in the room built Microsoft Word? There are different constituents, right? There are different people doing different things. There are
Have to test it either, right?
No.
You don't have to do it.
Right.
A survey on Microsoft Word.
Right, and the same can be true of more specialized things. Like we could say, what about statistics software, R or SPSS or something like that, right? None of us built it, but the companies that built it often worked with users and often do work with users. So there are people who are responsible for the tool building, and there are people who are responsible for tool using, and they often have overlap. But they're different people. They're different, and they have different motives. Some are trying to make money. Some are trying to help. Some are just trying to do the science, right? So 1,000% agree. Yeah, I don't think that's kind of one of the arguments is that I don't want to see yet another master's or PhD student reinvent sonification toolkit, right? There's enough there, or there's enough of the guts that hopefully, if there's value in this, that someone will make a really good one and make it available and support it so that next generations don't have to do that.
But are you asking the scientists to do evaluation? Or are you suggesting they could partner with someone who could evaluate?
Okay, so yeah, let me be a little bit more precise. There's the tools, and then there's the science, but there's also the communications, for example, or the artifacts or the things that you create. And so if you are making a visual graph, and you make a visual graph and you show it to somebody and they're like, I don't get it. Well, it's clear that this is my data. Yeah, I don't get it. Okay, you go back and you tweak the graph, the visual representation, so that that person gets it, they understand, right? They're picking up what you're putting down. You're doing the science, but part of the science, as Scott was saying, is communicating. And so they may have to, not necessarily, depends who, if you work for NASA, you're communicating to school kids and adults and scientists. If you're if you're working for the World Health Organization about vaccinations, you're communicating to policymakers, doctors.
At some point, but it's not always.
There's still someone that you're communicating with. And so if you can figure out whether your communication, if your message has been received, right? That's the kind of, that's the minimum evaluation.
But I can't think of a research. I can't think of I mean, maybe people can point it out, but I can't think of a research paper where I saw people test the line graphs or the histogram on 100 people and evaluated it and got a survey.
Yeah, because
and I think it's like I'm just concerned that with all good intention, but accidentally throwing barriers in the way of scientists using sonification for research.
Well, so somebody invented the pie chart. Someone invented the stacked bar graph, and there was a time when those did not exist. And so there was a whole field of InfoViz that spent 30 years studying those things, and now we just use them. So somebody's got to do the work to build, and someone's got to do the work to refine the tools and to make sure that we come up with these standards and these design guidelines so that people can just use them.
And I'm agreeing with that.
Yeah, yeah.
I'm just wondering if it could be partners doing it
Yeah, of course.
rather than, kind of adding this extra burden of work onto the scientists.
Right. So if you're going to use something new, you're making a choice to be a bit of a trailblazer. And so if you want to use same old, go use visual graphs, and you just pull them out of D3 or high charts or Excel or whatever, right? Yeah.
But you seem to be saying, if you want to do sonification, you are required to do a survey and compute the p-values and do everything like evaluating the statistics of the survey.
I absolutely did not say that.
No. But it seems
What
to
I'm
be
saying
implying-
is that you need to evaluate your work, and evaluating can come in many flavors. But if it's as simple as I'm trying to make a display for children, I'm going to put it in front of the children and see what they think about it. Right? That's an evaluation.
What if it's not for children?
If it's for adults, I'm going to see whether they actually
What if
get
it's
it.
for colleagues, peers?
Yeah. I'm still
Same
going
thing.
to.
What if it's for the people in your research group?
There's no exceptions. If I'm trying to communicate something to someone and I don't just communicate it, say it, and then look away and not look and
Right.
see whether they
But you
actually
didn't
understand.
you don't have to do a survey when it's like 5 or
You
3
have to do an
people.
evaluation to whatever degree is going to help you know whether you were successful or not.
And if
Sometimes that's just
if you
listening.
discover some new science as a result of it, is that not efficacious enough?
Maybe.
Or if you want to evaluate it and you work with somebody else who's educated in human factors,
Yeah. So
could
yeah,
that be the approach?
we may need to wrap up.
Yeah, I'm just gonna say that we can carry this on in coffee, but Mike has been waiting very patiently to ask a question. So we have one question, then coffee, or we can continue.
We'll let's extend this. Yeah.
I think I can try and get it anyway, so it'll be fine. So I was thinking about your statements about futuristic adoption of technology and wondering, is there if you would be willing to speculate on some way that we could short circuit the process in sonification? We have these tools. Is it as simple as we can scrape down all of the data that people have put into papers and make sonifications out of it using the defaults that you've told us work really well in high charts? Is that bad? Is there a reason to do that? Are there other paths that we could do to short circuit this adoption so that people aren't scared when they see sonifications?
When we think about it in sort of just a regular technology way, so making the utility greater and the cost less, the cost benefit function, right? As Amy was pointing out, if we can make tools, we can make knowledge available, and the costs of doing it are lower, and the utility is the same or higher, then that's going to drive acceptance and adoption. It's when you think about it as a futuristic technology. Many of us don't think about sonification in those ways, but many of our colleagues who are those scientists who are like, I would never do that, or flying cars, oh no. We have to also consider the other kinds of risks, also consider the emotional aspects, and make sure that you're not just in a cold space of here's the value of this thing and here's the costs of using it. Have to think about people's perceptions of their own fragility and their own reputational risk and their own ethical risk and those kinds of things.
What if I produce like a million of them pushed through high charts?
Yeah, one of the things that is doing is actually giving people familiarity, right? You're demonstrating that this can be done. And so we've done lots and lots of demos, but the more people will be like, oh yeah, familiar, not scary.
We community stuff, I should push everything through Spotify. You know, every like there's nothing stopping.
I have ideas for a test on radio to Sonify everything.
Is that bad?
No, as long as you're actually going to get some kind of feedback. It doesn't have to be a survey, it doesn't have to be statistics, but close the circle on that. Like, did that help? You could make a bunch of crappy anything, and if you just make them and put them out there and you don't actually, see whether it was any good, at some point it'll stop. This is not even science, this is marketing, right? So if you make a product and you put it on the market and you don't actually count how many of them are returned, you don't keep track of customer complaints, you don't keep,
Can I comment on this? I'm going to overrule Carrie's
Yeah.
Carrie's power here. I mean, I think that
Yeah,
it's your fault, fully. Didn't take it back. No, I mean, I think part of it is getting this out there, right? Like, I am someone who has not done this before, and I'm sitting here and I'm like, I'm giving a talk next month, and I'm like, I may sonify some of my charts for this talk, right? And so I think that like getting it out there and making it more accessible is one step, right? Like, and when I've told people that I'm here, they're like, they kind of give me this funny look, like, what is this? Like, it's a weird thing, because I have never once seen someone in my field do this.
It's a flying car.
Yeah, exactly. And so it's like totally weird. And so, but I think that just like getting the access and getting it out there, like, and I'm thinking like high charts I was playing around with the other night after you showed it. And I was like, this is super straightforward. And just now I was like, oh, there's one more step. I gotta download my data, put it over here, upload it. But I was like, what if I had an R package where I'm analyzing the rest of my data and it just automatically had like even like a GUI plugin that generated, that could allow me to do it at the same time I'm making the visual representation, like sort of which all. And like I think part of that is tool development, but part of it is just like getting more than just, no offense, but everyone who's doing it talking to each other.
Yeah, and so when we built the Sonification sandbox back in the day, after that, every conference that I went to, every research talk that I gave about anything where I had a graph, I would put a video of an animated graph. But the thing is that I didn't have or take the time to say, okay, here's what you're going to hear, right? I didn't have the first 2 minutes of that Aura, prep. And it was a cold audience. They didn't know anything about it. So either I spend the 2 minutes getting them up to speed so that they can listen to it, and then the rest of the time I'm talking, they're thinking about that and not about the things I'm talking about. So it's actually counterproductive in that ecosystem, right? So I thought, well, I could do it, but I'm actually sabotaging things, right? And you want to be careful that people are not going to throw the baby out with the bathwater.
But I guess I'm wondering, if you start simple, you actually don't even need explanation, assuming that everyone can see the plot, right? It's
right.
It's going from black and white to color, right?
Yeah.
We don't need the explanation of it necessarily. You're just adding.
And that's what I still often do is now I've got over that hump and I say, you know what, I'm just going to put it there. I'm going to play it. And people who are looking at it, they just see the graph because they know how to understand a graph. And they're like, oh, that's cool. There's some sound out of it. Ignore, right? Right. It's planting seeds. So yeah, so maybe if we all just did this, and now it's getting to the point where it's fairly straightforward. You'd have your data and you have it in R or in Excel or in whatever you're using, right? MATLAB, whatever, and you kick out a static PNG or a JPEG, and then you take that and you embed that in your PowerPoint slide or your Word document or your LaTeX or whatever. The process of many of these tools is identical. You have your data, you kick out now a PNG, but also a video. So grab the video and embed that in your slide instead. And best of both worlds, same workflow. So then the question is, do you just throw it in there and, and you play it and people can ignore or not, and then it just becomes commonplace.